43. To increase the brightness of a desk lamp, a student replaces a 50-watt incandescent light bulb with a 100-watt light bulb. Compared to the 50-watt light bulb, the 100-watt light bulb has which? Does it have less resistance and draw more current, less resistance but it draws less current, more resistance and draws more current, or more resistance and draws less current? So let's think about this in terms of Ohm's law. We know V equals IR, right? So now this thing's plugged into the wall. So you only can get one type of voltage, right? When you, well actually that's not quite true. You could have multiple different circuits, say in your house, where one of the circuits is 120 volts and another one is 240 for like a large appliance or something like that. But typically speaking, when you plug something into a general convenience receptacle in your home, you're only getting one type of voltage. It's probably a 120 volt circuit, right? So if that's being held constant, then the relationship between the current and the resistance is going to actually be pretty clear. The higher the current, the lower the resistance. The lower the current, the higher the resistance, right? So, and now what's power? Power equals IV, right? And there's some other formulations we can do by making substitutions from Ohm's law into the power formula. For example, if we plug in for what the voltage really is, it's really IR, in for V, then we get I times IR, which is I squared R. So the power is related to the current and the resistance, and that might come in handy too. So let's think about this. When you have this light bulb that's 100 watts instead of 50 watts, does it have less resistance and draw more current? Well, if the resistance goes down, then absolutely the current's going to go up, according to Ohm's law, right? And would that result in a net power increase? Yes, it would, because the current is being squared and the resistance isn't. So 1 is very plausible, and I think it's the best choice. But let's go through the others. Less resistance and draws less current. Well, if it has less resistance, it's going to draw more current. We just said that. So it couldn't possibly be less and less, unless the voltage was lower, and it can't be because that's being held constant. So 2 doesn't make any sense. What if it has more resistance? Would it draw more current? No. If it had more resistance, it would draw less current. So that doesn't make sense. And so now 4 is the other example. If it's more resistance and less current. But let's think about that now. If it's more resistance and less current, then what's going to happen when we go to calculate the power? We're going to have more resistance and less current, but the current is being squared. So that's having more of an effect on the power than the resistance is. So it's more important that the current be increasing, even if that means that the resistance is lower. So the best choice is 1. 1 is better than 4.